This is my third run at trying to track down the NGC Rounder series of 2550 to 2638 tonight. And the reason it's being challenging is because I'm using the ASI Live program. The scope is mounted on concrete. This is the portable Quatro 150 fast Newtonian. And the problem is that I'm not familiar with this interface. However, it does introduce noise reduction, but every time you do a new study, you have to actuate and clear the previous stack, which is getting to be a bit problematic. I've also discovered that you have to be very sensitive about your histogram settings. What we're looking at is a galaxy from last night. It is NGC2549. Tonight we're going to feature 2550 to 2638. Looking through the list, there were two that were unfound previously. They could turn out to be stars. But if we look at this screen, and I'm not going to spend much time on it, we got a beautiful view of an edge-on galaxy. Magnitude 11.2, 3.9 by 1.3 with an average surface brightness of 12.8 and a position angle of 177 degrees. Described through a 13.1 inch scope by Steve Gottlieb, who I quote throughout the evening in this Rounder series. Fairly bright, fairly small, edge-on, 4:1 aspect ratio, oriented north-south. Unfortunately, this looks east-west. 2 by 0.5 arc minutes, very bright core, stellar or almost stellar nucleus, located 10 minutes west-northwest of magnitude 5.9, 30 Lynxus. And you can see 30 Lynxus right there. We have a good focus tonight because we are getting the cross-hatching of the secondary mirror mount. I don't want to spend any more time on this. It's actually 9:35 on the 22nd of April, 2025. All right, we're now having a view of NGC 2550, which is our first study of the evening. It's located in Camelot, Dallas at 8 hours, 24 minutes, 34.4 seconds, with a northerly declination of 74 degrees and 44 seconds. This is a magnitude 12.8 galaxy, kind of small, 1 by 0.4, which is actually quite small for a 12th magnitude galaxy. Surface brightness of 11.6 and a position angle of 103 degrees. And now I'm going to do a little bit of a zoom in. I do believe the galaxy is located right here towards the center of the field. I got a pretty good alignment today. There's another galaxy here and a very edgy on one there. Some beautiful views. I am using ASI Live, which stacks the images and also allows for depixelarization. All right, so I'm assuming that this is NGC 2550, and we're getting quite a good view. At 2002 through a 17.5 inch scope, Steve Gottlieb says it's moderately bright, moderately large, elongated 5:3 aspect ratio. Oh, that's 2551, which we'll view next. 2550 is 17.5 done in 1992, so he had this scope for quite a while available to him. Fairly faint, moderately large, very elongated, 3:1 in an east-west orientation with an even surface brightness. This is our view. There are a couple of other beauties here. Nice edge on, and you can see the spiralicity in this galaxy located right there. And that we're going to move on, and hopefully those galaxies will be annotated as well this evening. Well, folks, I have to say this is going to take a while to do, because using ASI Live, we end up getting, even though I turn off imaging, it continues to image even when you have it turned off. So it's going to take a while to get this view here. I am going to zoom in a little bit, and we are looking at this galaxy right about here, which is described as NGC 2551. It's at 8 hours 24 minutes 50.2 seconds plus 73 degrees 24 minutes and 44 seconds. So a bit south of NGC 2550. Visual magnitude is 12.1. Size is 1.7 by 1.1 arc minutes with an average surface brightness of 12.6 and a position angle of 55 degrees. Boy, that screen is looking ugly. Anyway, not sure what exactly is going on. I'm going to stop the scan and reinitialize after it completes a 10-second cycle. Reinitialize it. Start with a new empty stacked image. And now we finally got rid of the light, the striations in it. Here's our galaxy at 250x. And that was NGC2551. Through a 17.5-inch scope done in 2002, moderately bright, moderately large, elongated 5 to 3, southwest to northeast, 1.3 by 0.7 arc minutes visible, southwest to northeast. Now the orientation doesn't quite look like that. This is west, this is east, this is north, this is south. Yeah, southeast to northwest, or vice versa. We can go with that. I'm going to go ahead and move on to our next study and see if I can puzzle through this interface by first stopping image capture, and then I'll pause and record it. Here we're having a low power view of NGC2552. Obviously a relatively immature galaxy, but quite large with a lot of light spread out. We're operating right now about 70x, so we need to zoom in, enhancing the brightness of this largish, faint, probably a class BC spiral galaxy, which basically does not have a starry core. But let me give you the data. I'm going to push it up to the 250 standard we ordinarily use, 80, 90, 100%. All right. So NGC 2552 is in length at 8 hours, 19 minutes, 20.2 seconds, plus 50 degrees and 26 minutes. Composite visual magnitude is 12.1, but it's quite large, 3.5 by 2.3 arc minutes, and an average surface brightness of 14.2 with a position angle of 45 degrees, which I would tend to agree with. 13.1-inch scope in 1985 revealed it to be faint, moderately large, and elongated. He doesn't mention the core. We are seeing a bit of the core here. However, the luminosity of this particular galaxy, NGC2552, does spread out rather evenly without any real signs of transition. All right, we're looking at a beautiful edge-on spiral galaxy, NGC2591. It's in Camelot-Pardalis. It may have been the one we saw earlier. Let me get this pointer out of the way so you don't have to look at it. 2591 is in Camelot-Pardalis at 8 hours, 37 minutes, 25.9 seconds, plus 78 degrees, 1 minute, 34 seconds. It has a visual magnitude of 12.3. Its size is 3 arc minutes by 0.6, so its surface brightness is about 12.8, with a position angle of 32 degrees. Through a 17.5 scope done in 1992, Steve Gottlieb describes it as faint, narrow, edge-on, 6-to-1 ratio, southwest to northeast, 2.4 by 0.4 arc minutes, with a brighter middle and a very thin, faint extensions. I would say we're getting a little better view than that. We can make out the core, we can make out the extensions. They are very, very nice, knife edge sharp. However, the galaxy, even at low power, gives a fabulous view. And at 250x, you can see the core, you can see an H2 region here in the core region, and here you can see the extensions going all the way up to about right there and towards the south and west. Very vaguely, with a little less luminosity going towards the north and the east. Very fine view. Beautiful edge-on galaxy. Dallas, NGC 259. Now imaging NGC2600. And we finally entered into Ursa Majoris from Camelopardalis and Lynx. NGC 2600 is at 8 hours 34 minutes 45.1 seconds with a declination of 52 degrees 42 minutes 57 seconds. It is a fairly faint galaxy, which probably won't register at 70x here. Visual magnitude 14.2 with a size of 1.2 by 0.4 arc seconds. Look for something edgy on. Surface brightness is 13.3 with a position angle of 78 degrees. Through an 18-inch scope. I will tell you more about that after we zoom in reasonably. Last galaxies were over here. There's several Edgion galaxies on this screen. Wow. It's hard for me to tell which one is which, but let me give you the description. NGC 2600 is, through an 18-inch scope, is first in a group of 5 NGC galaxies. At 280x, which we're very close to here, appeared very faint, small, elongated 2-to-1 east and west, 30 arc seconds by 15, with a low, even surface brightness. All right, I am thinking, let's see what he said here. 30 by 15, 2-to-1 aspect ratio. I am thinking this is the galaxy right here, but because there are 5 or 6 NGCs here, it's very difficult to determine that's the one. But the one with it looks fainter. These are the fainter galaxies here. There's also this edge on here, this edgier on the mostly edge on one at this point. So 1, 2, 3, 4, 5, 6, 7, could easily be 8 galaxies in this 250x field of view, which is probably no more than 20 arc minutes across. So take your pick, NGC 2600. Well, our next study is NGC 2602, and I challenge you to guess what kind of study it is. Well, yeah, if you guessed galaxy, you got it right. We're looking at a part of the Milky Way where there's very little in the way of new star formation clusters. Even planetary nebulas are relatively in abeyance here, and certainly not a lot of cold dark matter, so we are looking through a hole into deep space. NGC 2602 is magnitude, and I want to confirm that, 14.7, tiny, 0.4 by 0.2 arc minutes, which means it's something like 24 by 12 arc seconds in size. It's got an average surface brightness of 11.8. Well, yeah, because it's so tiny, now the average surface brightness increases with a position angle of 26 degrees. All right, and I am going to do our zoomy thing, and we're going to need as much of that as possible, although there is something that looks galactic in that location. Now remember, I can't push beyond 250 simply because the field of view gets so small. Now, there's no way that I can confirm that any of these particular galaxies, 1, 2, 3, 4, 5, 6, 7, 8, is the one we're interested in. But I would assume the alignment went pretty good this evening. That is probably our galaxy at NGC 2602. And let me give you Steve's description to help us out in terms of ensuring it's the case. NGC 2602, Ursa Majoris, 8 hours 35 minutes 4.2 seconds, plus 52 degrees 49 minutes 54. Visual magnitude 14.7, size 0.4 by 0.2. We got all that earlier. Through an 18-inch scope, extremely faint, very small, elongated 3-to-2, south-southwest and north-northeast, 20 by 14 arc seconds in size with a low, even surface brightness. Yeah, I do believe we can possibly attribute that description to this tiny little galactic faint presence located here on the screen. Okay, now we're off to NGC 2603. confirm that on the hand controller. Yes, indeed. It is located at 8 hours, 34 minutes, 31.2 seconds, plus 52 degrees, 50 minutes, and 25 seconds in the Big Bear, Ursa Majoris. It has a blue-violet magnitude of 16.42. This is a threshold study for this scope and this ZWO system. And a visual magnitude of 16.2, that gives it a delta of 0.22. That tells me this is a very, very young galaxy. Size is 0.4 by 0.3 arc minutes through a 24-inch scope. On March 13th of 2010, Steve reports that at 320x it appeared extremely faint and small, round, 6 seconds in diameter. So basically it's just visible at the eyepiece of a 24-inch scope operating at 320x. Whoa, this should be a nice test. So let's do our zoomy function. Now we're going to be seeing something over in this region here. This is 100x. Now this is an edge-on galaxy. It's not what we would expect to see. However, there is a faint galaxy here and a brighter or condensed galaxy there. There's also a very faint galaxy located here. There are numerous galaxies sprinkled throughout this field, any one of which can be magnitude 16.2 NGC2603. I'm going to give you that description again. Faint, it's a narrow edge on. No, wait a second, that can't be 2603. No. At 24-inch scope at 320 appeared extremely faint and small, round, 6 arc seconds in diameter. Well, the only thing I'm seeing, this is very faint and round. This is very faint and round. This is very... Notice there's a certain grayishness to these as opposed to the brighter whitishness of these stars like this. This may even be a very faint star. All right, all I can say, there's another faint galaxy there. So Steve's not reporting any other galaxies appearing in his field, and yet at this point here, we can say with some relative measure of confidence that this, we are seeing at least 16th magnitude galaxies. Well, kudos to that. Well, our next study is NGC2605. It's at 8 hours, 34 minutes, 53.4 seconds, plus 52 degrees, 48 minutes, 15 seconds in the Big Bear, Ursa Majoris. This one's slightly brighter than the previous. Its visual magnitude is 15.8, but it's quite tiny, 0.3 by 0.3 arc minutes with a position angle of 25 degrees. So that basically says the core is oriented in that direction. In 2010, on March 13th, Steve reports that 320x appeared very faint, very small, round, 12 arc seconds in diameter, located look for a bright star, 2.4 arc minutes southwest of, not a star, but another galaxy, NGC2602, and it is the fourth brightest of 5 galaxies. So apparently 2602 is the fourth brightest of 5, or perhaps 2605 is. It's very unclear to me. NGC 2606, the brightest member, lies 6.3 arc minutes to the east, which would be the left side of the field. Now, we don't expect to see any of those galaxies, faint galaxies, at 70x or so. So we're going to do our zoomy thing. There's a nice edge on right over here with some magnification. Very nice. Another bright edge on here, but we're expecting to see a galaxy somewhere in this region. There's a face-on right there with a little bit of extension, so it's not quite face-on, it's oblate. We continue to zoom in at 50%, 60%. This obviously is kind of an edgy-on galaxy. All these galaxies are now popping as we approach some 250x. So here's our 100% view, 250x. All of our pixels are being exposed. We've suppressed as much of the background pixelation as possible using ASI Live, and instead of ASI Image, we're seeing numerous galaxies. It's very difficult to determine when you've got 16th magnitude galaxies in profusion such as this, but we should be expecting to see the galaxy over here somewhere. There are dozens of galaxies all over this field of view. I'm sorry, I'm unable to identify which one it is, but we are seeing galaxies well beyond magnitude 16 this evening. No moon, clear sky, beautiful, using the ZWO imager through a 6-inch scope. Definitely, I would say we're rivaling the light sensitivity of a 24-inch scope without the aesthetics of actually looking through an eyepiece. We are now on to NGC2606, another galaxy in Ursa Majoris. It's at 8 hours, 35 minutes, 34.7 seconds, plus 52 degrees, 47 minutes, and 20 seconds. This should be a more obvious galaxy to identify. Its visual magnitude is 13.9. However, it's quite small at 0.7 by 0.3 arc minutes and with an average surface brightness of 12.5 and a position angle of 39 degrees. Through an 18-inch scope done in 2010, Steve describes it as faint or fairly faint, small, elongated 4 to 3 southwest to northeast, 35 by 25 arc seconds. And it says, a note, 18-inch eyepiece seems to be limited to magnitude 14.5 visual. That is something that I noted when I was collecting all this data together. And yet we are imaging galaxies to magnitude 16 and beyond. Let's do our zoom and pick out this galaxy. There are several edgy-on-looking galaxies here. I would expect this to be the galaxy based on the position of the screen. NGC2606. Let's go ahead and push it up to 250. And there is our 100% view exposing all of our ZWO pixels, which is about a little more than a half-inch by half-inch CCD imager, maybe 15 millimeters, I'm not sure, to photonage. Very, very nice. Well, there's supposed to be a meteor shower tonight, and clearly while photons were being collected using ASI Live for stacking purposes, a meteor flew straight through the middle of the screen. What we're looking for here is NGC 2614. It is a galaxy, of course, at 8 hours, 42 minutes, 48.2 seconds, plus 72 degrees, 58 minutes, and 35 seconds in Ursa Majoris. Visual magnitude 12.9. Very large for almost 13th magnitude galaxy, 2.5 by 2 arc minutes and an average surface brightness of 14.5 with a position angle of 150 degrees. And you can tell that that meteor image basically passed right over the heart of this galaxy. Through a 17.5-inch scope, in 1992, it was described as very faint, fairly large, 2.5 arc minutes in diameter round, very low surface brightness, very weak concentration with no core. Well, that corresponds quite nicely to what we would expect. Now, as we zoom, we are beginning to reveal a core. Take a look at that. 100% view, we have a core with a very face-on galaxy, completely circular in its aura. This is quite a nice view. Now I could stop the stack and then we'd have a better view of the galaxy, but I'm really kind of running out of time. We're into this for 24 minutes now, and I had several abortive starts to begin with while I was getting the procedure down for ASI Live imaging. So let's just stay with that image and also say we saw one of the meteors. I'm not sure, however, I'm not a big meteor fan, so I'll have to look up what meteor shower was expected last night and this night. Apparently we didn't move very far, nor did we have to worry about the meteor trail, because NGC 2629 is quite close to NGC 2614. 2629 is located at 8 hours 47 minutes 15.8 seconds plus 72 degrees 59 minutes and 8 seconds in the Big Bear, Ursa Majoris. Its visual magnitude is 12.3 and its size 1.8 by 1.5 with an average surface brightness of 13.2 and a position angle of 105 degrees. We will do our zoomy thing and then I will give you the description. We're probably going to lose the last galaxy, but let's see. I'll pause for a second. You can see it right there. There is a very sharp edge-on galaxy there. There is some faint luminosity over here. Our galaxy is probably this one right here, and it will bear a significant amount of magnification, just like the edge-on galaxy. So here is our view, and let me see what we got, 150%. I'll drop it down to about 120. Now we should stay with our standard, 100%, 250 plus X. Other galaxies are also in the field. Let me give you Steve Gottlieb's description of NGC 2629. He said through a 17.5-inch scope then in 1992 that it was fairly faint, small, slightly elongated, definitely elongated, 4.3 west-northwest to east-southeast. It's got a small bright core with a faint stellar nucleus and a fairly high surface brightness. Yep. I would not describe it as having a stellar core. The core seems to have been is quite distended. It's very flattened egg shape with a very pronounced aura around it. And it is fairly intense to the view. And of course, my eye tends to want to go to this beautiful edge on above. Let's see, maybe we will be imaging that in particular this very evening. Well, it looks like our edge-on galaxy located right here may very well be our next study. It is slightly to the east of this lineage of two galaxies, this faint face-on and this brighter elliptical here. So therefore, it would end up being a little later in the catalog. This is NGC 2630. There's no description. It's at 8 hours, 47 minutes, 6 seconds, plus 73 degrees in Ursa Majoris. And there's a note here that Corvin did not find this galaxy. Clearly, it is a bit too faint. And the eye would have been distracted by this face-on and this bright elliptical. So there is, in fact, a galaxy which we can easily say could very well be NGC 2630, and I would have to collect data on it tomorrow. I'm not sure whether Corvin, who I'm not familiar with, although I've seen the name several times, what scope he may have been using to find this galaxy, but it is quite present on the screen, and I would venture to say it's probably somewhere around magnitude 13.5 to 14. So it's rather inexplicable that it didn't turn up. Well, we've pretty much stuck to the same field for NGC 2631, which in this case, Steve Gottlieb says he could not find, and presumably he would have looked for it with the 24-inch scope. So what I'm going to do is zoom in, and we'll see if there might not be another galaxy, and there certainly is. One right here, but we're operating way up in the magnification range. So basically, this is about 500x, and here's our edge-on galaxy. So it's entirely possible that at, let's say, 250x, that this is our NGC 2631. It is quite forgivable that it may not have turned up. Have a look at comparing this, what may be it could be considered a star by some, with this, which is an actual star. This one over here is probably about a half a magnitude brighter, but it is well condensed in its luminosity. This one's a little bit fainter, but it doesn't appear as well condensed in luminosity, so presumably this is a galaxy. Not a bad catch for the NGC2631, but it needs to be confirmed before we can be certain about it. Well, several galaxies in this field as well, but it's not in the same region of space. What we should be looking for here is NGC2633. NGC2633 is located in Camelopard, Dallas in 8 hours, 48 minutes, 4.6 seconds, plus 74 degrees, 5 minutes, and 55 seconds. Visual magnitude 12.2, so quite present on the screen. Size 2.5 by 1.5 arc minutes and an average surface brightness of 13.5. Position angle is 175 degrees, so pretty much east or west. Through a 13.1-inch scope done in 1986, Steve describes it as fairly faint, small, bright core with faint extensions slightly elongated north and south, and it forms a pair with NGC 2634, 8.2 arc minutes to the south, which would be above.